Hey there guys, and welcome back to another video on my channel. And in this video we are going to talk about why do we need file handling. So all these variables in the program are only available to you till the program is running. So say for example I store data in my I store students data in my structure student variable st20. So I store say 20 students data, and that 20 students data will be only available to me till my program is running. After my program is completed, or say I close my software, I will lose everything. And if I need the data again, I will have to run my program, and I will have to input that data again to have it in my program again. So basically there is no data retention, or there is no saving data. So to save data, what we can do is we can get the data from the program while program is running and make the program write data to a file. Because even if my program stops executing or completes, or even if I close my software, the file will not be deleted. Okay, unless until I delete it. So that's thing. So basically file handling is the very important part for any type of data you want to save even after a program is completed. Like for example, say your save games in a file, so that whenever you launch the game you can continue from where you left off. So that's file handling. And another example is interfacing between two different softwares. So for example, your software 1 and software 2. Software 1 does something and gives an output, and output of software 1 should go to software 2. Okay, so what you can do is you can write the output of software 1 in a file, make software 2 read from that file so that it can use the output of the software 1. You will see that in this program or in this video right now. So let me just quickly explain this fwrite function first. The fwrite function basically is a function to write bunch of data to file at once. How it differs from putS is that putS will only write a string to file. This can work for pretty much any data, like this structure over here, or an array, or normal data as well. So what this fwrite function takes is, it takes to the reference or an address, like the scanf function takes to the variable where you have kept your data. It takes the size of the structure you are giving, or basically the size of the variable you are giving. So we wrote here the size of the struct. So this will return basically the number of bytes required by this structure student variable. We can also write over here simply sti, because that's the same thing, because whatever size my structure will require, and each variable will require that same size, but the convention is this, so we'll keep it this. And this is basically this one over here basically is the number of times you want to write the data at once. So we want it to only write one structure variable at once, so hence we are going to write 1 over here, and then fptr takes the file where you want to in which file you want to write the data. And similarly the fread function is kind of similar. It takes the pointer to the variable where you want to save the data from the file, or where you want to store the data which you will get from the file. Takes the size of the data type which you are using to store the data in, and takes how many number of data you want to read from the file. So we are reading one at a time. And this fptr is obviously the file pointer where it wants to read the data from. And I have done this over here. I have checked while you have something to read that and store in the step structure variable over here, and then just print the step name and step role. So this program over here will write data into file, and this program over here will read data from file. So I'll just quickly do a rundown for the programs. So I have declared a file pointer, student structure array for 20 students named st, integer I and num for my loops, and open the file in fptr, and the file name is test.dat right now, and I've opened it in WB mode. So this means write, and B means binary. So this will write, this is used to write data in binary formats to file. Okay, I have checked if the file pointer is pointing to nothing, which means the file was not opened. Print error in opening file, and then simply exit the program. And this exit 0 function is in stdlib.h, standard library.h. And then I have asked it how many students, and then I have inputted that number of students you want to input data of. Then I am pretty much simply taken input one by one for each student and write it into the file. So here's I have taken input in for students data, and here's I have written that to the file. And over here I have kind of done the same thing. Declared a file pointer, declared a structure variable step for storing data which I'll be getting from the file. Open the file in the test.dat file in read binary mode, which means read binary file, and checked if the file does not exist, and that means the pointer is pointing to null or nothing. Print error and exit the program. Exit is again in standard library. Then while you can read the data from file, read it and set it to step, and that means set the data into step function, step variable over here. So store the data into the step variable. Then I have printed the data in the step variable. So I'll now just quickly run this and show it to you guys. So first we are going to write the data. So I'll compile my writing program, which is io.c. Now I will run it. I will enter data for 4 students, roll name first and roll number then. So and then I'm going to enter Rick in roll number 2, Elena roll number 3, Kayla roll number 4. And now we are going to run our GCC io2.c. So I'm going to compile io2, which is basically the program which will read from the same file. And as you can see, it read from the same file and printed me the data as I inputted it. Now I'll show you the file, how the file was written. So Kate is the text editor. So see this. This is how my data was written. My structure was written as it is, but these are actually bulk characters, some characters which can be basically bytes and stuff, which are in fact bits, which are zeros and ones basically. And this Kate, it cannot read them in the encoding mode. I have opened it, so hence it's showing me the errors, or this error, and showing me the boxes and brackets, and only showing me what the strings I have stored and nothing else, not the roll numbers, in case you didn't notice the roll numbers are not here. So those roll numbers are basically over here. So this is one roll number maybe, and then this is one roll number maybe. This is the roll number of Rick, and then maybe this is the roll number of Elena, and maybe this is the roll number of Kayla. Maybe because I cannot read those boxes obviously. But if you see that when we read from using the program, it read absolutely fine because we opened the file in the read binary mode. So the CF read function already handles those binary data. So what it does is basically it will convert that binary data into what data it is supposed to be, and then set that to the structure variable. So this is how you use fread and fwrite function, and this is why you use file handling. So if you have any doubts, please leave it in the comment section below. Thanks for watching this video, guys. Not much stuff left in C now, maybe a couple or 3-4 more things left. We'll quickly round it off, maybe 2 or 3 more videos, and then you're all set to do your own coding. So thanks for watching this video, guys. Please leave a like and subscribe to my channel, because there's going to be a lot of important stuff, tips and tricks, tutorials about computers and programming, and some gaming content as well on my channel. And I hope you will enjoy it. I think you will enjoy it, so I'm saying subscribe. So no more sellout, sorry. So thanks for watching. Goodbye.